Hi, my name is Tiffany Trixie and I will be presenting on the introduction. Chemical fertilizer application has increased in the past decades in agriculture industry in order to enhance crop yields. However, the increasing amount of fertilizer use does not result in a rise in crop yields, whereby the crop yields stagnated or even declined in some countries. Therefore, in this project, we aim to adopt a zero waste management approach using a process control system, specifically a pH control for precision fertilization control of fertilizer integration system and water to improve the performance of the fertilizer system.
Next, I will talk about how the control system is implemented in the water fertilizer integrated technology. You may wonder, what is the water fertilizer integrated technology? It is a technology that carries out the fertilization and irrigation simultaneously to increase the utilization rate of fertilizer and water, hence leading to zero waste. There are numerous control systems, but the one that we focus on is the pH adjustment process. As shown in this figure, this system mainly consists of pH sensor, controller, solenoid valve, and irrigation and fertilizer pump. There are two inputs, which are the fertilizer and acid, whereas the output is the mixed fertilizer solution. So this system works by mixing the fertilizer and water, then the solution's pH is tested using the sensor. When the pH does not meet the requirements, the valve of the acid tank will be adjusted to obtain a suitable pH value. Moving on to the controller used in this control system, there are four controllers being compared, which are the PID controller, Fusey controller, Fusey PID controller, and PSO Fusey PID controller. By comparing all controllers, PSO Fusey PID controller is the best controller as it is capable in dealing with continuous problems such as the fertilizer application system. Besides, it can provide fast response, small overshoot, and relatively low steady-state error.
Assalamualaikum, I am Amal Firdaus and I would like to present the critical analysis of our water fertilizer integrated control system from a chemical engineering aspect. As mentioned by the previous presenter, the PSO Fuzzy PID control is the controller utilized in this control system. The PSO stands for Particle Swarm Optimization, whereas Fuzzy stands for Fuzzy Logic. These two plays a very distinct and important role in the design of our controller. Firstly, a fuzzy logic imitates human reasoning. In the case of Boolean variable in computer which can only compute values of 1 and 0, a fuzzy logic is able to introduce intermediate possibilities between the values 1 and 0. It is also crucial as it is able to solve non-linearity, which is our main concern during pH leveling. Second, PSO is a type of AI algorithm that shares information between individual agents to find an optimal solution. It does not involve complex ideas of coding and is simple and is able to operate efficiently. Then we are able to design our controller. The benefits of our controller is discussed in the next slide. From the experimental results, a comparison between all controller is simulated in a MATLAB environment. The graph shown determines the time taken for each controller to reach a steady state. It can be seen that the PSO Fuzzy PID control is the quickest controller to reach steady state. Next, from the table with different pH values, it is observed that PSO Fuzzy PID control has the highest amount of green compared to other controllers. However, the rise time of the Fuzzy PID control is bad, indicating that it takes a greater amount of time for it to respond, but is still able to provide minimal overshooting and rise time.
Furthermore, irrational supply of fertilizer in agricultural industry causes severe environmental effects. There are mainly three of the effects, which includes effects on water pollution, on air pollution, and also in soil pollution. Therefore, in this short presentation, me, Dr. Guardiola, would like to explain in detail about these three effects of irrational fertilizer supply. First of all, it is the effect on water pollution. So irrational fertilizer supply may cause severe water pollution. Since there are many suspended solids in the water, basically heavy metals, it may cause three problems, which are water leaching, drainage problem, and also surface flow problems. And also, accumulation of high amount nitrate in drinking water may cause severe illness, such as goiter, birth defects, heart disease, and blue baby syndrome. Besides water pollution, irrational usage of fertilizer in agricultural industry have also severe impacts on air pollution. First of all, when the nitrogenous fertilizer itself is made, greenhouse gases like CO2, CH4, and N2O are created. It is therefore produce harmful greenhouse gases that reduce the ozone layer's ability to protect population from ultraviolet rays. And when it compared to carbon dioxide and methane, nitrous oxide itself has 310 times more potential to cause global warming. And last but certainly not least, its effects on soil pollution. First of all, soil acidification and soil crust formation may occur, which lowers the amount of organic matters, humus, and beneficial organisms in the soil itself. Secondly, a lack of micronutrient supply into crops and damaging the topsoils, which lowers the crop yields itself. And lastly, the soil itself becomes toxically contaminated with heavy metals, including uranium, cadmium, and arsenic. Therefore, with all these three impacts on environmental, it is very need.
Next, we move to challenges and recommendations. The first one is electrical interference, which is the fluctuation readings of the pH value due to electronic noise. For instance, when the mixing motor is turned on, it may generate 1 to 2 volts of electrical interference into the liquid whose pH is being measured. As noise is a shared signal, it is detected by both the pH and reference electrodes. Since the reference electrode is grounded in the asymmetrical mode, electric noise is present solely on the pH electrode. As a result, the noise produced together with the pH signal will amplify, hence producing fluctuation in values. One way to overcome this problem is that the reference electrode should not be grounded. As a result, the electrical disturbance will be present on both the pH and reference electrodes equally. Therefore, it becomes a common mode signal and can be dismissed by the operational amplifier. Relay halting around the set point is a common problem in the soil fertilization sector. To make this clear, assume that in a typical scenario, a low set point of seeds pH has been selected. The pH value would start to increase due to the addition of caustic solution, and the pump would simply stop when the pH value reaches 6. However, the pH would fall back below 6 as the mixing pump would still continue to operate, and this will cause the cycle to start all over again, hence resulting in the hunting relay around the set point. One of the ways to overcome this problem is by allowing the pump to continue to dose even beyond the set point. From the preceding example, let's say the pump will continue to dose until 6.5 pH. As a result, when the dosing pump is turned off, the pH may decrease to 6.2, which is still over the set point, therefore hunting can be prevented. The pH mechanism of strong acid, strong base is highly nonlinear. A fixed controller such as PID cannot efficiently regulate this process. In practice, most pH loops are in a bang-bang type of control with pumps cycling on and off will result in huge oscillation. Since acid and caustic neutralize each other, overdosing acid and caustic is extremely costly. The MFA pH controller can effectively control a wide range of pH processes within the full pH range. Moreover, MFA pH controller also enables automatic control of acid or alkaline concentration, both which are critical quality variables for the chemical process industry.
Hello, my name is Putu Nur Aisyah and I will be explaining on the conclusion part of this project. As a conclusion, fuzzy PID controller is chosen to build an integrated water fertilizer control system focusing on pH control, at the same time to prevent wastage of the water and fertilizer consumption. From the result that were obtained, fuzzy PID controller has an excellent dynamic performance at a variety value of pH in a comparison to the traditional PID control and fuzzy control. Hence, we can conclude that the objective of this project, zero waste management approach, is achieved from the overall report. That's all from me, and thank you for watching.